This video will review some of the key ideas in the alcohols topic for OCR A-Level Chemistry. This first section, we're going to be looking at the physical properties of the alcohols. In addition to being able to name and draw structures of alcohols, we're specifically looking at the bond polarities within alcohols and using hydrogen bonding to explain water solubility and that low volatility compared to other organic molecules such as alkanes. When it comes to naming alcohols, we're following the same pattern of looking for our longest carbon chain, any side groups, and obviously focusing on the OH group. Here we've got 1, 2, 3, 4, 5 carbons in a chain, so we're thinking about pent. All the carbon bonds are single bonds, so an, and then carbon 1 is where the OH group is. This number needs to be as small as possible. Carbon number 2 is where we see our methyl group. Second example, 1, 2, 3, 4, 5, 6, 7. Hept. Again, and, because all the bonds are single bonds. And on carbon number 1, we have our OH group. Carbon number 3, we have a chlorine atom. Now here, 1, 2, 3, 4, we've got bute. All the carbon bonds are single bonds. Now we have to decide, do we number from this end or from this end? We're always going to make this final number for the OH group as small as possible, which leaves the methyl group on carbon number 3. Now, here's an interesting example because we have 2 OH groups. So this is going to be a diol. I can see 4, so bute, and all the carbon bonds are single bonds. But when we've got 2 alcohol groups, we leave the eon, butane, rather than just butan, and then the 2 numbers, 1, 4. Put hyphens around the numbers. Butane, 1, 4, diol. There must be a comma between the numbers. And then on carbons 2 and 3, we have 2 methyl groups. So 2,3-dimethyl, butane, 1,4-diol. The key point about physical properties and alcohols is the presence of the OH group. We have got a hydrogen attached to an oxygen, so we're going to have a very, very, very polar bond, and the oxygen has 2 lone pairs on. So what we're going to see is hydrogen bonds between molecules. When we talk about hydrogen bonds, we don't mean this bond here. This is not the hydrogen bond, this is a covalent bond. Hydrogen bonds are intermolecular forces. So if I were to think about a molecule such as ethanol, which I'm drawing skeletally, there will be an interaction between ethanol molecules and water molecules. Put our bond polarities on for the OH bonds, put the lone pairs of electrons on the oxygen, and then we can see that there will be a hydrogen bond between the delta positive hydrogen of one molecule and the lone pair of electrons on the delta negative oxygen atom of a different molecule. So I could have drawn it like that. Alternatively, I could have had an interaction between the lone pair of electrons on this oxygen and the delta positive hydrogen in a water molecule. It doesn't matter which one you draw, only draw one. Don't try and get clever and draw multiple hydrogen bonds between two molecules. Don't do that, just draw one. Alcohols have high boiling points for organic molecules. So if I were to think, again, I'm going to go to ethanol, keep it simple. I need to put my lone pairs of electrons on my oxygen atoms. I need to put my bond polarities onto the hydrogens and oxygens, and then draw in my hydrogen bond. This hydrogen bond, which I must label, I must always label the hydrogen bond, must be between the lone pairs, a lone pair of electrons on the oxygen and the delta positive hydrogen. So this is what helps explain the higher boiling point. I need to put more energy in to overcome this intermolecular force of attraction, which is why alcohols have higher boiling points, which is why they are less volatile. Remember, volatility is about how easy it is for a substance to turn from a liquid into a gas. So their volatility is lower than similar molecules, like similar alkane molecules with similar MRs, and their boiling point is higher.